So you heard what I said, so I'll skip through that. Right. So whenever data is entered by a user, it should be checked on the form using form controls and JavaScript. Date should normally be entered using a calendar because the user can type the date, but it will be shown on a calendar for passive confirmation, or he or she can pick things off the calendar, which is better. Address lookups are cheap and widely available now, so they should always be used to enter or at least confirm addresses. Email addresses should always be checked. We'll look at that later on. And user training may be needed to explain why users can't just type anything anywhere. We've had all kinds of things like users typing in a contact's name as "please delete this contact." So that a letter gets sent to Mr. Please delete this contact. So it's very important that the developers and the users work together to make the system do what they want to and make them understand that that's nasty. Said my internet connection is unstable. Make users understand that they do have to play by the rules. Data from databases can be guaranteed to be clean in various ways, but only if you're using a proper relational database and only if you're using it properly. We're going to come back to this. Data from files may have come from a database. More likely, it has come from Microsoft Excel. And the two boxes at the top here. So the top one is a file that I created, just a text file. I loaded it into Excel. Well, it was a CSV text file, comma separated variables. Loaded it into Excel, saved it again, and it came back like the one below. And we see errors like this in systems all the time, leading zeros, missed off phone numbers, strange formats for things that weren't what we expected. Character, like the pale yellow one on the left, character set mismatches. Because Excel still thinks that everyone should use Windows 1252, whereas in fact, over 99% of the internet now uses UTF-8 and most applications do. This is an annoying thing that Microsoft misuses this byte order mark thing, it's shown in the black there, to say that this is a UTF-8 file, as if that isn't the default, and it isn't for Microsoft Excel. So it's not a tool for preparing data. I mean, it's got lots of good uses, but preparing data isn't one of them. Strangely, Microsoft suggests that you should prepare your data like that for if you're running Dynamics, for example. If you listen to this program from Tim Harford, more or less, it's quite old now, but you can still get it, I think. It explains some of the really big Excel errors that have happened, data quality errors. Data from API calls usually means data delivered as XML or JSON. So XML and JSON include metadata as well as the data, like they contain the field names and sometimes more than that. But there's no check that the data actually matches what the metadata says it is. You get that in a database, it won't let you put things in the wrong kind of data into a field. But XML and JSON is just a text file. So if you're receiving messages like this, they need to be validated before being used in an application. Automated feeds from devices. I worked for a car insurance company that installed boxes in the policyholders' cars to record location, acceleration data, which was sent back to a central database. You'd think that would be pretty reliable. But every now and again, we'd get a data point with a latitude and longitude of 00, which is that point just off the west coast of Africa. So if someone's going down the A3 and then suddenly you get the 0 point, they seem to be going very fast. So we had to clean that data as well and really check that it was what it was supposed to be. Uh, Another thing that happens with that kind of data, you may have experienced this yourself using SatNav, or well, you wouldn't get this example using SatNav, but the same kind of thing is when I was working in London, I'd come home to Faversham by train, and if it was dark and raining, I'd like to check where I was. So I had all my bits together to get off the train. And the top left there, you can see that we were going along uh, the railway track, and then suddenly we jumped to the road. And that's because this circle is the accuracy. The circle on the left there is the accuracy of the reading, and it's only within about 100 meters there. So it guesses that, of course, I'd be on a road, not a train. But when the train track and the road diverge, and that circle doesn't include the road, then it jumps back to the train again. So getting those kind of things from cars was tricky, where you got a motorway next to an ordinary road. Um, you'd suddenly see the car as if it were on the other road, and that would kind of change what you think the speed limit should be, for example. If you have parameters from files to start up your application, then they should be controlled by scripts which are in the version control system as part of the release. If such things can be different every time the application starts, that is unfortunate, and the application must check that the set of options it has this time does make sense. It's a pretty dangerous thing to do, really. So that's a brief overview of the sources of data. So I'm going to change gears now and talk about defect clustering. So if we're looking at programming, writing applications, typically in a system with many components, about around 5% of the components will account for about 50% of the defects. There have been lots of studies that have shown very similar numbers to this. That means many components will be defect-free from the day they're written, which is great. But another impact of the way that defects appear in our systems is that the more defects you find in one component, the probable number of remaining defects will be greater. It seems counterintuitive. You know, you've fixed 20 defects, so it ought to be all right now. But actually, it's a bit like if you see a cockroach on a wall in a restaurant, you don't think, there's the cockroach, somebody killed it. You think this place is infested, and program code can be like that. It was formalized back in 1979 by Thomson and Shelson, noted down at the bottom there. And what they did was to track testing of components. So the number of tests performed on the x-axis and the number of test failures on the y-axis. And so as you go along on the white line, you find one, you know, a few bugs, and then you don't find any more. So you say, okay, you fixed all those, this is acceptable. But if you're on the black line, and every time you continue testing, you find more bugs, and it eventually gets into that reject area, then you want to reject that thing. I think the concept is great, and it's good to understand that this kind of thing happens with testing and bugs and clustering of bugs. But quantifying this is impossible, really. How do you measure the amount of testing? How good were the tests? How granular were the tests? And therefore, how do you know where to put those three areas? So I've never seen a practical use of this diagram in a real situation, but I think it's good to understand the general principle. And when you get redesign it, recode it. And the same applies to data as well. If you keep getting dodgy data from a source, then it's probably going to give you more dodgy data. So how can we test data? Well, we've mentioned some of these, the form controls, the API calls, trees from devices, and parameters. But there's more to say about databases and files. So we'll do that now. I think the easiest way to test data that arrives in a file is to load it into a database and then use the database facilities and techniques described in the next few slides. So, do you have a suitable database? Well, my favorite is Postgres because it's free. It runs on Linux, Windows, and Mac, and it's really robust and scalable and very, there are lots of bits of design that are better than the other databases. But you can do this with any database. It'll just be a bit more difficult. Postgres has a great command called copy, which lets you take a CSV file and load it straight into a table. And that makes it very easy. The description in the Postgres documentation about what a CSV file should be is the clearest I've ever seen. And you really need to be aware of eccentric CSV-like formats. I worked on one where they had a 2-character delimiter. It's completely unnecessary and it just makes it a lot more complicated. Anyway, so you can load your data into Postgres or whatever database you've got. And I'll go through what we do by looking at a case study that I was involved with. So I was working for a leisure company that did a deal with a large supermarket chain. The supermarket's customers got information and discounts on leisure services. And the leisure company gets a list of the contacts who may be interested in its services. So I was the data guy, so I got a file of 26,000 contacts to add to our contact database, which already had many hundreds of thousands of contacts already. And so I had a quick look at the file and I could see that it was a CSV file with the following fields in it. So I put it through a profiler. You can buy profilers. You can download mine free from my website. I wrote it because clients were reluctant to spend £100,000 on a profiler, even though I told them how useful it was. So I wrote one that I could use anyway. So what we get from this, and it's pretty similar in the commercial ones as well. We get a list of the columns on the left, and so the first 5 columns in this table are from the metadata in the database about the columns, what the data type is, defined length, whether they're allowed to be null or not, and if they are, how many nulls are present. And then we get on the right hand 2/3 of this information about the actual content of the data, but a summary of what the data looks like. So we can see the percentage populated and just one here that, although most of them are allowed to be null, there's just one here that had a few nulls in, otherwise it was pretty well complete. But not everybody wants to give their phone number, so that was fair enough. An interesting thing here, how many distinct values you've got. So the row count in this table is 25,984. The club card number, 25,984 distinct values. So they must have been unique. You'd hope that would be true, but you might have collected the same one twice. And then you can go on to look at frequencies and patterns. which so frequencies. This is test data, I should say. I didn't use the real customers' data, and my test data generator was a bit silly about titles. um, these are all realistic and very similar to the source, but I don't think there are 14 brigadiers. Anyway, but the real data had this kind of pattern where there were about 12,000, 13,000 misters, and then the sum of Mrs., Miss, and Ms came to about 12,000. So that doesn't prove anything. We don't know what the makeup of the leisure company's customer base is, but it looks from this as though it's pretty even, male and female, and a few people with titles. So those frequencies are very useful for checking the data, and it means you can see if there are any odd things as well. And then patterns. So what was this? Oh, this was telephone number. Yeah. And you can see that mostly it's a list of decimal digits. So we've got a space in. Oh, and so we've got a plus here means a mathematical or other symbol. It could be a plus or something else. It's likely to be a plus because you use that in international numbers, but you know, we can check that in detail. We know we've got a few to look at. So we learned from the profile that the club card number is unique. It always starts with a 7. Consent 1 and consent 2 are not interesting because they're always yes. Created date is always in 2023, which is good because that's when they did the exercise. Email address has some errors. We could have picked them out on the profile, but we'll see them in a minute. The full name looks okay. Phone numbers are inconsistently formatted. And titles were okay, except that they've been told to put in MX, meaning I don't want to tell you whether I've got a male or female title, and they put in XMX, which was pretty easy to fix. Email addresses. So email addresses are defined by several RFCs. That's request for comment, and it's a thing that's not quite as standard. Things become RFCs, and then after they've had the comments and sources and all that, becomes a standard, but with email, it never did. And different organizations, different companies that process emails will actually have different rules. So you can have an email that works with one particular emails provider and one and doesn't with others. But generally, they're pretty consistent. You've got a maximum length of 320 characters. You have to be a bit so. Some characters are not permitted in some places. Actual accepted addresses are often more restricted than the standard. There are dozens of validations available. We tried some that rejected valid email addresses, so we got rid of those. So the one we used, shown in the next slide, does find many genuine errors, and we've not found a valid email address that it rejects. There may be some, so it may not be. It may be infallible. May not be infallible. It may be fallible. Right. So we could run this select on our marketing list table that we created. And the bit that does the work is the highlighted bit in yellow, which looks a bit horrific, really. It's called a regular expression. And every time I write one, I go to this website, regex101.com, because not only does it help me write it, but it will let me test it as well. But once you've got one, that describes a pattern, a legal pattern of email addresses. And this is the sort of thing you get out of it. It's not so easy to see the errors there, so I'll highlight them. Right. So that hyphen in the first one, and the fact that it's got 2 @ signs, that's a mistake. The next one's Gmail, nothing, should be gmail.com or whatever. Um, you see various things, double at signs, slashes instead of dots, spaces in the name. You can't have spaces in a name in an email address. So this picked out genuinely mistaken email addresses, transcribed properly or noted down, transcribed improperly or noted down wrongly. And what we did then was if we had a phone number, we'd phone the person and try and get their correct email. Works the other way around as well. If they're both wrong, it's a bit difficult, really. But what we don't want to do is guess. We want to check with the user what the email address should be. Telephone numbers are surprisingly complicated. The rules defining valid phone numbers vary within and across countries and over time. I don't know how many of you remember when the London numbers changed, but they do change over time. The recommendations from Ofcom are that you should be allowed to write down your phone number with spaces and brackets and parentheses in it if you want, and that should be all right. But that flexibility can lead to ambiguity. So this one, with the plus sign in the front, well, people do that, but the plus sign means it's an international number. So if that were an international number, it would get you to a corporate network in Kazakhstan. It's probably got a zero in the front and it's a UK mobile, but we would need to check with the contact using hopefully a correct email address so that we could get that number right and consistent. There is a really comprehensive tool from Google. Not my favorite company, but there you go. This libphone number is a Java library containing about 4,000 files of reference data and code. It looks pretty good, but it's not foolproof. And it's not completely up to date. Not their fault, actually, that it's not completely up to date because the international authority doesn't keep them up to date. Where I was working, they didn't want 4,000 Java files from Google, so which was quite sensible. So we came up with a simpler solution, and I'll show you what it looks like. It does find some errors. And what it found was that most of the numbers were good, but there were some there were some missing, which was acceptable. People didn't have to give us their phone numbers. And there were 3% that were errors of various types, which are listed by the query that we ran. Right. So you can do quite a lot about phone numbers and making sure that they're useful and correct. Another kind of data error is duplication, and that's very, very common. It can be in your database. Yeah, they have duplicates in your database. It can be in files and other inputs to your database, and it can be between your database and the data that is to be added. Microsoft provides in Dynamics 365 a bizarre way of looking for duplicates by specifying some first characters and some last characters. As you can see from this example, it just doesn't work. It's just useless. There is a very good way of doing it. using what's called the Levenstein edit distance. It was invented a long time ago, 1965, and it's in some of the better databases now, but not all of them by any means. So what it does is to look at two strings and say, how many edits do you have, single character edits do you have to do to change one string into another? So banana and Panama gives a result of 2. So you change the B to P, and you change the second N to M to get Panama. But pomegranate and Uzbekistan gives a result of 9. You'd have to do 9 single character edits to get to change between those two. So what we do is to look for pairs of records with 1 or 2 letter differences across all the fields that we're interested in. And that would be names, addresses, postcodes. And you can see some examples that we found here. Again, made up, but the same problem, but with different names. So if you look at the last one, so probably the real name is Prasad, and it's been put in as RRASAD. First name's the same, don't have the address town, the street is the same, the postcode's the same. Pretty confident, we can be pretty confident that those two are duplicates. And you know, they're both there because the surname has been misspelled in the first one. Again, I would do a lot to avoid guessing what it might be. If we can get in touch with the person and see how their name should be spelled, or if they've, what their postcode should be, or whatever the difference is, and we can get that put right. Missing data. So this suggests that data exists somewhere, but is missing from our particular application database. That's often happening. And if we're synchronizing with another system, so if we've got a data warehouse, for example, that's synchronizing with a production system, we may fail to copy some of the records for some reason. So we need to run regular reconciliations to make sure that our two databases are in step. Missing data. So I was working in a data warehouse, and we'd actually collected all the data from the various systems that were to go into one new system. And a very big international consultancy was going to do this for us. So I asked him, the project manager, how he was going to reconcile the transaction table, which was 80 million records. And he looked me in the eye and smiled and said, "Oh, well, I bought a few records, of course. That is not good enough." I did tell him, but yeah, he's from a big international consultancy, so they did it anyway. I mean, it can be a challenge to reconcile data record by record in two different databases. It could take a long time, and synchronizing frequently changing systems can be particularly difficult because one may not have caught up with the other one yet. But there are feasible things we can do. We can match the total record counts. We can try matching the record counts by year or month or day or some other partitioning of the data. Did we have this many records in the source system and the same number in the target system for March 2023? That kind of thing. We could select values from random records in one system and compare all the values with the same records in the other system. That's a reasonable sampling thing to do, but you need to do an awful lot to be really confident because these data defects, if you've got 80 million records and 10 of them are different, it's going to be quite hard to find those 10 by sampling. We could use hash values on the data as we do with file downloads. That's another way of checking that we've got exactly the same thing, but that won't tell you where the difference is. So there are things we can do. We've emphasized the need to trap bad data on the way into the system. We can make improvements, but we cannot expect to catch every error. We can often limit the impact of data errors by detecting and acting on any unusual data patterns or events. And when we do find another error, we add it to the monitoring and keep that check, especially after the error has been fixed, because we get regressions coming back. I think it's because we tend to fix the problem based on a scenario that's caused it, but there may be other scenarios which cause the same problem. That does happen. So we may not have fixed the whole problem. We fixed a bit of it. So again, there's a monitoring tool that you can get from my website if you want. I've never seen anything else quite like this. I didn't invent it. I was working for a guy who said, what I want is something that does this. So I built it, and we used it. Well, I've used it in many systems now. So we have a summary screen where we look at various subject areas and record the number of failures in each area. Most days it'll all be green if you've got a decent system, and that's great. But you want to spot it when it goes red. So that was always the first thing I looked at. And on this particular case, this is based on a real situation. I was working for a payment processing company, and we were loading an awful lot of transactions every day. And when I drilled down to the errors on that system, we could see that we got the number of transactions being 6.5 million, and that was 2.5 million different from the previous day. And I'll explain that against this chart. So we look at the change from one day to the next. That's a common thing. We may look at absolute values. We can do those kind of charts as well. But and in this case, we're looking at 6 months. We calculate the standard deviation of the change over that period of time. And then we look at today's value. And if today's value is within 1 or 2 standard deviations, you'd expect that to be 95% if we've got a normal distribution. And normal distributions are very common, but beware, if you've got some other kind of distribution, it won't work. And it does work for this kind of thing where we don't know all the factors affecting the number of transactions in a day, but we do know that they vary. So in this kind of thing, we'd expect 95% of the results to be in the green area between 1 and 2 standard deviations of the mean. If it's between 2 and 3 standard deviations of the mean, then we'd only expect about 5% there. And that's already 100%. We'll come back to that. It's not quite 100%, but about 5%. So, we'd expect sometimes to see things in the yellow area. And if it's more than 3 standard deviations from the mean, that's about 1/3 of 1% on a normal distribution. So 1 in 300. We'd expect then to get one of these a year. And we might not worry about it too much. So the one that happened in December there, it might have been around Christmas time, lots of extra spending on credit cards. That one is not so surprising. We still want to check what it was. But this one that I saw one day when I came in and checked it was, a big change from what we expect. So my first thought was that we loaded the transaction table twice. That wasn't the case, as it happened. Oops, let's go back and explain that. The date of that event was Friday, the 13th of April, 2018. It isn't because Friday the 13th. It's unlucky. We're not superstitious. And anyway, this is a change that happened on the 12th, the data for the 12th. If you're a horse racing fan, you might be able to guess what that is. It was the Grand National. And people had started betting on the Grand National using payment cards. So that's what had happened. A lot of small transactions, and that's what had also changed the average transaction value was much less than usual. So that had a perfectly legitimate explanation. But again, you can see that if something had gone wrong, we'd have spotted it, when we checked this in the morning, and we'd have been onto it pretty quickly. So this is an automated test tool for data. Each test is written in SQL. So you're very likely to have people with the skills to be able to do that. And you can use the automatic detection of unusual situations like the one I just showed you, or you can create your own test with specific limits. If you know this should never be bigger than a particular number or never be smaller than a particular number, you can actually code that in and get it to turn red if it's outside that range. And you can get it from my website, and you can contact me, but please don't do it all at once because it's just me and I'm retired, and I would get to it, and I would certainly be interested in helping you if you're using it. Since we are usually testing data with this monitor in a live system, we have to be careful about the impact we're having on that system because we're running some potentially big queries. So usually there's a quiet time at night when we can check everything. We 2, 3, 4 hours sometimes when we can run all our tests. If we're getting close to the time we have available for testing, then we can apply a classic risk analysis, which says what's the probability of this happening, in which case if it's quite likely to happen, then we want to check for it. And what's the impact? And if the impact is high, we certainly want to check for it. How do we judge the probability of a so far unidentified defect? No idea. But the impact can be very high. The thing from the first slide, the flight plan error, had a very high cost. The post office Fujitsu Horizon scandal had data errors, and the cost of that is rolling on even now. And that it turned into, of course, a personal cost, not only a financial cost. So checking data is good. So what I would try to do first of all is run all the tests that I want to run every night. If that takes too much time, it's quite unusual for it to take too much time, actually. But if it does take too much time, we could run tests less frequently, running some tests one day and some other tests the next day, and then the first test on the third day again. If we're confident that some data is static, if we know it's only changed once a month, then we can run the test just after it's been changed. So we need to apply that risk analysis, even though the probability is very hard to determine. Right. I wanted to come up with some kind of guidelines and practices and classify them, but I found that the classification is a bit fuzzy. So we'll have a fuzzy classification there. They won't all fit on one slide anyway. So I mentioned training users to respect data. No test data in the live system. You see this all the time. And correct data for every field. So that means as developers, we have to make sure that the users have the features they need so they don't have to improvise. Normally, if they put rubbish in, it's because they need to record that, and there's no way for them to do it that's defined in the system. The other thing is to make sure that users can quickly find the record they need so they don't create duplicates. That quite often happens where they can't find the contact's details, so they create another one. I mentioned not using Excel to prepare data. I always use UTF-8. I mean, you'll find old systems that are still on old encoding systems, but UTF-8 supports all the languages in the world. It's on almost all the pages on the internet, and it's supported by any decent software, so that's the thing to use. It will often be the default, but don't let Microsoft get you to use Windows 1252. When you find a data error, add it to the gatekeeping and monitoring, because it will probably come back, or there's a good chance it'll come back. Avoid large package solutions. People are buying Dynamics and Salesforce, and really you don't get the control, you don't get what you'd expect to get from these systems. They're not really great at looking after your data. And deliberately create, well, Dynamics for sure, deliberately creates duplicates, which is really irritating. Don't use a common data model. There is no such thing. Again, Dynamics, 700 or 800 tables, and you still have to add another 300 because your organization is different. So it's yeah. And don't use Windows for a server, because it's got lots of idiosyncrasies, and it still has a lot of use of the non-UTF-8 character sets. In terms of design, we should design our system to trap data errors at the gate to the system. Catch them on the way in. Don't let them cause havoc in the system. Validate and clean bulk data inserts. Don't just trust it to be right. In the database, don't use XML or JSON for structured data. You need to split that into its separate fields and store them in a normalized database so that you record each fact once only in your database, whereas XML and JSON tend to produce a lot of duplication. Do not repurpose things. This happens with the package solutions where they haven't got what you want, but you find another field which isn't being used, so you use that. So it's got a misleading name, and that causes a lot of problems. Deprecate is an ugly word. It means we're going to stop supporting this, so we suggest you do it a different way. Certainly when you don't have control over that with the Java language, for example, or Oracle, or Sybase with its timestamp, which isn't a timestamp. Those things are deprecated, but with your own systems, you should refactor it, correct it immediately, take the pain now, and then it won't keep poking at you for the life of the system. Don't add complication and flexibility unless the users actually need it. There are lots of systems which make things more complex and therefore more vulnerable to data errors when they're not needed. And store anonymized data separately. Don't just write anonymized over everything. That's a bad way to do it. Tools. Well, you can use database constraints to enforce having unique keys. That helps. You can use them to avoid having broken links between tables. You can use the data type system to make the data type as restrictive as possible. So if you want to store an amount of money in the database, then you say numeric 9,2, which means you can have up to 9 digits, which is a lot of money, and 2 decimal places for pennies. If most currencies are like that, but not all of them. But you can define the data type that suits your currency, and then you won't be able to put silly things like telephone numbers in it. It has happened. Use not null constraints. That's another database thing which says this field must not be empty. We absolutely need this to be able to do anything with this data. Use third normal form for all tables. Reconcile. So all those things to do with databases and using a relational database, they're very powerful tools for having highly controlled, consistent, well-defined data. Profiling new data sources, I find that's really useful. You catch a lot of things which you can save getting into your database, and set up automated data monitoring, whether you use mine or some other system. Just have regular checks running on your data, because they will find bad things. Okay, so I've rushed through that, and hopefully pretty much not too much over time, I hope. And happy to take any questions. So if I stop sharing that, I think we might be able to see one another.
Okay.
Oh, I can hear something very faint.
Right. So thanks, Ron, for that. I think we're just getting questions now. So in the chat.
There we go. Share.
So Olivia, in the last slide, what is the third normal form?
Right. Okay. It's an unfortunate term which is used to describe the correct way of designing a relational database system, the database structure. And it's just a set of rules which help you to parse the data into the separate things that it's describing. And I've got another whole presentation on that, so I'm trying to summarize it. But that's what it does. It's a simple set of rules where you don't have repeating groups inside a record. You don't have records which describe. So you might have a person who might have 0, 1, or more cars. You don't put the person and the car in the same table. You split them apart. So you record, but you link them together. So you record each fact only once. I'd be happy to, well, you can go to my website. You can find out about normalization, and I'd be happy to talk about it. But it's too long for a question to go into any more detail. Yeah.
Thank you for that. Any other questions? Rosalie said, could you expand on the point, do not use a common data model, please?
Okay, common data model I got. Was there a specific thing about that?
Or could you expand on the point, please?
Right. So the idea was that many businesses are very similar. Many charities are very similar. Many government organizations are very similar. They keep similar data. So why don't we just define it once and then everybody can use it? Well, the problem is, although that's true, although many systems have a person table and they have names, and those people have addresses, and they have something, maybe they have transactions, something about their relationship with the organization. But trying to define it as a standard thing, which is what a lot of the big applications have done, like Dynamics and Salesforce and like PeopleSoft before it, and any of the other so-called ERP systems. They've tried to define one model which works for everyone, but it doesn't. So you have to add extra stuff, and you have to fit in with what they've got already, and it doesn't fit properly. You wouldn't design it like that by choice. So I'm not the only person to say they're a mistake. The Margie Ross, who worked with Ralph Kimball and on his books and his training and his consultancy about uh, data warehouses, has written a very nice article about that, which explains why they just don't work. So you can't skip that step in your database design and just use a standard one. We'd all end up with a car that's got 12 seats and the ability to carry a ton of wood in the back, because that's the kind of standard. We all like to have different cars to suit our particular needs. It's the same with the data model.
Okay, thank you.
Does that help?
It does, I think. I'm sure you'll let me know. Any further questions, please? Okay, we seem to have another one, if I can get to it. So it says, it's a debate whether you buy off the shelf instead of building. Needs to come back on your previous point about the common data model.
Sorry, you're very quiet. So I heard.
Sorry, so I said, is the debate whether you buy off the shelf instead of building?
Right. I've worked with a lot of both systems. I've certainly seen some particular builds for particular organizations that have gone wrong, but I've seen an awful lot of these big, expensive systems that have gone wrong. I know after I retired, I started volunteering, helping out with data stuff. And I was involved with 5 different charities that bought one of the big packages, and 3 of them had to scrap it after spending millions. And that really upset me to see charity trying to do the right thing and spending a lot of money and then it failing. So they wasted £1 million. They don't get any refund from the vendor because their system didn't work. There's a recent one, Guide Dogs for the Blind. Absolutely tragic situation. I don't know who their software vendor is, but they built a huge system and they had to scrap it. They wasted that money. So when I say they built this big, huge system, as far as I understand it, it was a package solution which was customized for them. That's what normally happens. And it didn't work. It's amazingly, so people are afraid that if they go out to a software house and say, build us one of these, that software house will say, yeah, do it. And they might fail. But you can't assume that the big companies will not fail either. I've seen failures from Salesforce, from Microsoft Dynamics, from the Oracle systems, and then you waste a huge amount of money. So if you have some incremental development, you can tell pretty soon if the people doing it know what they're doing or not, and you might waste tens of thousands, but you'd have much more opportunity to avoid wasting a lot of money. So
Okay, thank you.
I would, there's only one exception, and that's accounting. And accounting systems, because in this country, because they're governed by accounting law, they pretty much have to work. Some of them are nicer than others, but I think I wouldn't do a bespoke accounting system for anything else. Well, I've never seen a package that did the right job. Yeah.
Okay, thank you.